Today, we're very happy to welcome Tim Weilkiens today to speak on AI and model-based systems engineering. Tim is a MBSE consultant, trainer, and CEO of oose and an active member of OMG and INCOSE. He is a co-author of the SysML v1 specification and a lead developer of SysML v2. Tim is involved in many MBSE activities, and you can meet him at MBSE conferences and book him as a consultant or trainer. Tim has written many books, including Model-Based System Architecture, AI-assisted MBSE with SysML, and Model-Based Product Line Engineering. He is the editor of the Pragmatic and Independent MBSE Methodology SysMod and founder of the SysML v2 Learning Club. Tim, we welcome you today. Thank you for being here.
Okay, thank you very much. Thanks for the invitation and for the introduction. So first, of course, let's share my screen. So welcome to this presentation. It's about AI-assisted MBSE with SysML version 2. So along with some drone examples, I will show you the next big thing, or the next two big things, SysML v2 plus AI. But first, before we start with that, why do we care about AI assistance and SysML v2, besides that it's really cool, but what's the real purpose behind that? Imagine now if we were still developing software with punched cards today, and that's long time ago. And this is what it would look like in software development departments then. And of course, that's absolutely nonsense. So if we hadn't developed our software development technologies further, we wouldn't have the system we know today, of course. So we don't use punch cards anymore. We must sharpen our saws. No? The markets, they request ever more powerful systems. Now that's the vertical axis here. So, and it's more complexity at the same time, shorter time to market, better quality, less cost, better features, and so forth. No? And the capability of our engineering tools, they must follow this curve. And people, of course, also play a crucial role here. So the project heroes, they can develop even better systems despite our tool limitations. But if a company now does not further develop the tools, so the engineering tools, which means the methods, the approaches, the practices, and also the engineering software applications, then we get this gap here of, let's call it the gap of laziness. No? And this becomes increasingly a problem then. So we need a continuous improvement of the engineering tools, and from time to time we need a larger step there. And introducing SysML v2 technology, AI assistance, these are two candidates to close this gap there. Yeah, so why can I talk about it? Well, improvement.
Pardon, yes. Jim. Tim, I need to jump in. If people could please mute, we're having some echoes, so if everyone except Tim can mute, please. Thank you.
Okay, thank you. Thanks. So improving engineering tools, like introducing AI stuff, SysML v2 in particular, that's my job. Janet already introduced me. So I'm trained on consulting for engineering methodologies, and I have written many books, a lot of books. Really many books. And one of the books is about AI assisted with MBSE. So I will come to that later, and other books are about SysML v2. So, well, I have many hats off. I will skip that. Let's jump into the real stuff and the real topic. So let's frame the topic first a bit. So the increasing complexity, I think, at all levels, technically, but also socially, organizationally, politically, and so on. This is certainly the main driver for us to continuously adapt our engineering methods to be able to meet this challenge. And a part of it is the so-called digital thread. So in an engineering project, as an effect of all this complexity is that we have a really large number of engineering artifacts. And nowadays, hopefully, most of them are digital. Yes, we still have some paper in our projects, but most of the stuff is digital. And all these digital artifacts are networked with each other in a variety of ways. And we call these connected artifacts the digital thread. And the problem is that in most projects today, there's no well-managed relationship between the artifacts or between all the artifacts. And it's a nightmare, of course, in particular when things changes and we don't exactly know the impact of the change on other artifacts. But unfortunately, it's daily business for most projects. But there's this vision that we, at some point in the future, we were able to manage the whole digital thread. So here's a simple example of this challenge of the digital thread. For example, you have requirement specifications in a document or a requirement management tool. So outside SysML, not SysML v2, and they are linked with source code because the source code satisfies the requirements. So this simple line on my slide is already a challenge for many projects. How to link source code, which is in a software development environment, with requirements in a requirement management tool, and have a stable link which is maintained over the time, so with all the changes. But we have more than source code. Now we have CAD models, and maybe they have also a link to the requirements because they satisfy requirements. But they are also linked to the source code because the source code uses some of the CAD parameters in the source code, things like that. And we have more. Now we have safety analysis, we have simulation models, we have life cycle assessment stuff, and so forth. And yeah, it's a nightmare to keep track of everything here. And of course, many errors happen. So now we have SysML. Well, SysML is not the silver bullet. It looks quite nice. It's like a sales slide here. So wow, now everything is resolved. But it's independent of SysML. It's in the nature of systems engineering in general to establish this holistic view on the whole system. And the system model, for example, using SysML, is a concrete implementation of this holistic view. And any specific engineering artifact, safety, CAD, source code, and so forth, has a direct or indirect anchor point in the system model, at least theoretically. Now, that does not mean that the traceability is also established in a real project using SysML. You get this not for free if you introduce SysML, but it enables this traceability. The SysML model here on my slide, it looks like the central master repository, but that's not the idea. It's more the glue logic between all the engineering artifacts, but that's hard to show, the glue logic between the artifacts. So that's not the intent that it's a central master. So we will come to this picture also back later because SysML v2 has a great contribution to it. Yeah, speaking of SysML v2, let's start with a brief flyover over SysML v2 before we move on to AI and bring the topics then together. SysML is a really big topic, so it will be very compressed and high level. Yeah, so what's SysML? Well, it's that's the definition of SysML from the SysML v2 specification document. As it says that SysML is a general purpose modeling language for modeling systems. And you can create and visualize models with it. And it mainly represents requirement structure and behavior. That's the main parts, but there's more. Now, there are also analysis cases, verification stuff, and so forth. But requirement structure, behavior, that's the main focus, I would say. And the language is independent of concrete methods and practices. It's only a language. So it's only one important, but it's only one piece on the table. We need methods and we need tools to make this working in a project. So that's SysML. And SysML is maintained by the OMG, the Object Management Group. The OMG is also responsible for many other specifications. I think they have more than 200 in their catalog. and SysML is only one of them. UML is another one, and they also have a lot of domain-specific specifications. That's the OMG. It's a member-driven organization. So any company that is a member in the OMG can join the standardization process for a specific standard. By the way, SysML is also defined as an ISO standard, so SysML version 1. And we are in the process to push also SysML v2 to ISO. Yeah, quick look on the development of SysML v1 and v2. SysML v1.0 was published in 2007, so a long time ago, almost 20 years, 18 years now. And the latest and last version of SysML v1, 1.7, was published in 2022. And the first steps for the next generation SysML version 2 were already taken back in 2009. So already 2 years after we published SysML version 1 with a so-called request for information. But things became then more concrete in 2014. So another 5 years later, where we started working groups working on the roadmap for SysML v2. And in 2017, the object management group officially published a request for proposal, which means a catalog of requirements for the new language. And the SysML submission team, SST for short, worked on the submission then in response to this RFP from 2017 to 2023. And in 2023, the OMG adopted this submission from this team. Says, yeah, this will be the next SysML v2. That's already 2 years ago. So the OMG only said, okay, that will be the next standard, but it's not final yet. So let's now finalize it. So at the same time, in 2023, they started the finalization task forces, and they worked 2 years on the finalization, and now we are almost done. We expect the final publication in September 2025. So the work is almost done, but there's an editorial process and administrative stuff, and so that's still going on. But the work is done for SysML v2.0, and we already think about 2.1, which is then the next one. So that's the history of SysML version 1 and version 2. So who's behind that? Well, the members of the OMG and the people from the submission team, the SysML submission team, and this team had more than 200 members from 85 different organizations. So it's really, really a community effort. So it was not an ivory tower of a few people. It's really a community effort. So different organizations from all over the world. Officially, this team ended with the start of the finalization task forces in 2023. But to keep this pace of so many engaged people, the OMG started the systems modeling community, which contains many working groups working on different aspects of MBSE and SysML v2. And it's easier to join for people to join the community than to join the OMG organization. In particular, it's cheaper to join only the community, but you have no voting rights on the standards, but you can work in the community working groups. Yeah, so check out the OMG website if you're interested in that. Yeah, to give the whole thing a few faces, I'll show you some of the group pictures. The working groups behind SysML v2, they meet 4 times a year for real. So this is a meeting from 2017, long time ago. I think this photo was taken in Europe, in Brussels. So I'm the second from the right. In the middle is Sandy Friedenthal, so Mr. SysML. 2019, and over the time, the interest grew in SysML v2, and so did the group. So we were not 200 people from the beginning. That is 2019 in LA. Well, if you remember 2019, 2020 was then COVID. So we had in 2021 the next meeting in Rio, still with some limitations. So you can see this here on the picture. And here is 2024. This was Chicago, and the last meeting was 2 months ago in Reston near Washington, with a lot of people from the team. And with SysML v2 shirts. So this is these are the people behind the standard, or some of the people behind the standard. So let's have a look on the cover features of SysML v2. So the most important features, at least, that would be on a cover page, not all the features of the language. That would be too much for the time we have here. So one of the most prominent features, the most visible feature of SysML v2 is, of course, the notation. And the same for SysML v1, which is based on UML, Unified Modeling Language. And on one side, the diagrams, which is, so to say, the user interface of the languages. And SysML v2 has two phases. It has not only diagrams, or we call them now views, it also has a textual notation, and that's a big change. So here's an example of the two phases. On the right side is the graphical notation, an example of a simple structure of a drone. Now we have a part definition of a drone, which has a battery and 4 engines. And on the left side, the same model in textual notation. And that's completely new. Now, the graphical notation, if you're familiar with SysML v1, well, you see some differences. Of course, there are some differences, some new errors. And if you look in detail on this, then you see rounded corners and square corners and things like that. But well, in the end, we have boxes and lines. So it's a graphical modeling language. So that's not a big thing, I would say. Of course, some people, well, change always leads to resistance. And I know that some people already complain about the symbols they don't like and so things like that. But the really big change is on the left side. We have a textual notation. It feels like a programming language, but it's a notation. So the real model, the model data is in the background in a repository, and we can show it graphically and we can show it textually. And it's a complete. And you can use both. Finally, it depends on the tools that you use. So if you hate graphical modeling, then only work with the textual language and vice versa. So it's not mandatory to use both. You can use it. It's only an offer from the language, a capability of the language. And this is quite interesting. So the textual notation, that's a real door opener, in particular for software engineers. Software developers, well, of course there are exceptions, but usually they don't like modeling. They don't like this drawing of boxes and lines. They love their development environments, where everything is more or less text-based. And those development environments are really, really powerful. So it's okay. I can understand that they don't like to draw the boxes. And since there's hardly any complex system without software, it is important, of course, that software engineering works closely with systems engineering. You probably know this hotspot in projects between systems engineers and software engineers. So very often I observe that this is more a hotspot with conflicts than a nice collaboration. So that's tricky, the interface between these two. But now with the textual notation, it's a door opener, and software engineering and systems engineering can move closely together. We can already observe that movement. You can also observe here the magical door that absorbs software engineers here. Whatever that means, maybe that's just AI is not perfect yet. But we come to AI later. Yes, most SysML v2 examples on slides and presentations are system structures. It's easy to show them. They are not so difficult to understand. But here I give you a very brief overview of examples of behavioral modeling. So we have 3 different kinds of behavior modeling in SysML v2. It's almost the same as in SysML v1. On the left side, we have actions. Looks like an activity diagram if you're familiar with SysML v1. So we can specify the execution order of tasks performed by a system. In the middle is a state machine. Of course, SysML v2 also supports state machines and can be much more sophisticated than this example here on my slide. And on the right side is what we call in SysML v1 or UML the sequence diagram, which basically contains the information that parts sends messages to each other. So that's here graphical notation. We can do the same in textual notation, but I will also skip that one. But you can model it completely textually, actions, states, and the messages. Yeah, another big change or cover page feature of SysML v2 is the API and services. That's really a sparkling game changer, which enables the model interoperability and much, much more. So you remember maybe this picture here, this slide from the beginning of my talk. And in practice, the challenge is here that all the different tools at the bottom connect to a SysML modeling tool. So if you already do or did this in your projects, now you know that it's not easy to connect a CAD tool to a SysML modeling tool or a safety analysis tool to a SysML modeling tool. You need specific adapters provided by the tool vendors and so forth. And this is where the SysML v2 API comes into play. It's there. Now we have a standard how to access a SysML model independent of the SysML modeling tool. So the API is standardized. Technically, it looks quite simple. Now I can read elements, I can write elements, I can delete elements, things like that. SysML v2 supports two concrete bindings, so implementations of the API, which is part of the standard. One is REST, if you're familiar with this. So you have a URL of each model element, and you can access it by the URL. And the other one is oose. But you can also have other implementations of the API. Not shown here in this slide, it's a little bit simplified, but of course on the other side, so the CAD models, the simulation models, and so forth, they also need tiny plugins, extensions to get this functionality to access the SysML v2 API, and much more important to understand what they get from the SysML model, because they get SysML v2 data, model data, in a JSON format, and of course they must be able to interpret this stuff. So that's the API. I have some examples here. So for example, on the left side, let's see, you see it's safety gaze, that's the name. It accesses a SysML v2 model through the API and retrieves safety relevant information and shows them in different nice views. And nowadays it's quite easy if you're a software engineer to develop really quickly nice views and web-based stuff like this one. And the information comes through the SysML v2 API. So it's stored somewhere in a SysML v2 repository generated by whatever tool. At the bottom, you see, well, Tom Sawyer. Tom Sawyer has a SysML v2 viewer, which is a SysML v2 visualization tool. So it accesses a SysML v2 repository through the API and provides the really cool visualization. I will also show a bit of it later in the demo. We have more here. We have here. Let's take this at the bottom. Yes, that's Word. It's a requirement specification document in Word, and it accesses also the SysML v2 model through the API to get information about variability, feature model information, and can then select or deselect parts of the text in the specification document depending on the selected feature. So this goes into the direction of product line engineering. And the same at the top. At the top is an open source feature modeling tool. It's called Feature IDE. It also retrieves the feature information from the model and creates the feature tree in this tool. So these are only 4 examples, no? And it's extremely powerful that we can now really use information stored in a SysML v2 model. It's not a silo anymore. We can access this information and show only a specific aspect of it, no? Things like that. That's quite nice. So, well, introducing SysML 2 in an organization, that's definitely a big impact for the organization, although it's only the language, but language is an important pillar. And even if the change is welcomed, it's a challenge. Now, organizations are complex, and every change leads to resistance and behavior that is difficult to plan. You probably know that stuff. And so if you're already tearing up your road in your organization to lay the SysML 2 line, then you should also lay another line before you close the road again to open it again a few weeks later. So, because the next change is just around the corner. And well, that's AI. Let's skip to the AI topic. The text notation is a door opener for software developers, but it's also a door opener for large language models. You can use also AI as an assistant for SysML v1 without the text notation. There are already plugins for some modeling tools available to provide AI assistance in modeling. So it's already there, it works. But well, if you know ChatGPT, Claude, and so forth, all the AI, Gemini, the LLMs, well, they are text-based, and the text notation on SysML v2 and the LLMs, that's a really good match. Yeah, and I think it was already 2 years ago, maybe 3 years ago, that Doug Rosenberg contacted me with the idea, well, Tim, let's use ChatGPT as an AI assistant for MBSE processes with SysML v2. So Doug Rosenberg is the main author of this book. Maybe some people know Doug. He has written also many other books, and he's in the community, in the modeling community, since the 1990s, starting with UML version 1. And Brian Moberly at the top, he also joined this book project. So this book is about doing a quite complex project from the beginning until the simulation and mock-ups and prototyping of this project using AI assistance. And I'll show you some examples that goes into that direction. So first, of course, AI is a broad field. We always say it's AI. What we mean is large language models. And typically it's ChatGPT, but there are also other ones. So we have defined an AI persona. It's always good to provide context first if you talk with an AI. So here we have our persona, Forrest Einstein, and he's an expert for forest fire observation drone systems. So drones that fly over forests to detect forest fires. And now we ask him for some use cases, and he provides a list with a brief description of each use case. So detect the fire, monitor the weather conditions, survey vegetation, and so forth. So AI is good to generate stuff with this Gen AI. You probably already have tried that, in particular generating cool videos and pictures and stuff like that. But AI, they also have a huge domain knowledge which you can use. So even if you are yourself already an expert of those systems, you get sometimes some good additional stuff. But it can do much more. I will come to that later. So here, now, of course, you can argue whether these are good use cases or not. Now, there are so many different methodologies about use cases, and I will also come to back this later. So here it's a zero-shot prompt. We just said, you're Forrest Einstein, you're an expert for forest fire observation systems, list some use cases, and that's the result. So without any further guidelines for the AI. So speaking of generating cool images, that's not only fun, you can also seriously use this in workshops. So here this way, for example, we can visualize use cases directly Here the prompt is create a graphical storyboard for the use case detect fire. And then we get the storyboard of this use case. Since AI also likes to hallucinate, of course, it can be quite funny, the result. But this can also be very, very helpful in a workshop. And of course, there are also really good suggestions in the pictures. So it's really valuable and very quick feedback. It's a quick feedback loop for initial ideas. If you already did use case workshops, well, it's really abstract now. If you do directly in the modeling tool, you have the ellipse symbols or boxes in the tool, or you use cards on a wall or things like that. And now you get real pictures for it. You can create comics or photorealistic pictures, so everything is possible. And it's a really nice, quick feedback loop. And if it creates stupid stuff, then it's funny, which is also nice for a good energy in a workshop. Yeah, you can even create videos, cost a little bit more time, and watch your system in action at a very early stage. So, of course, it's not a simulation, and it's full of vagueness, but it's a first simple feedback loop of your system. So, using the domain knowledge of AI is only one aspect. And normally, the knowledge of that domain should already be with the people in your company. But AI can definitely provide support and give feedback on certain aspects using images and videos, for example. An interesting use case using AI assistant is changing the roles. So here it's Trudy, and she's a production engineer and delivers use cases like design drone hardware, develop production process, assemble drones, test the drones, and so forth. And you can also turn the AI into a safety engineer, an assessor, a hacker, a competitor, and so on. So allowing you to analyze and to challenge your own development from different perspectives. Of course, it's probably much more productive if you ask those people in person instead of an AI, but you can do this very quickly in a single workshop. And in most cases, well, of course, it depends on the project, you should do both. This is not a replacement to ask your production engineers. But very quickly you get input from this perspective. You can switch the roles even to people who are not accessible or not so easy accessible. So this is really nice. This is also nice not only in engineering, so maybe you have to write a speech and you use AI to create the speech, or you send your speech to the AI, and then you can say to the AI, well, now you are a competitor, what would you say? Or you are a bad person and who likes to crashes my speech or so. And then you get really good feedback. So this changing roles is quite nice feature. Yeah, so coming back to our use cases, now we have another AI assistant, and she's AI MBSE expert and familiar with MBSE methodologies. And you can easily train an AI by providing examples. That works really nice. So here we limit ourselves to the documentation structure of a use case. So we say, okay, a use case has a name. At the top is always a verb plus a noun. So like detect fire and not detection also. It's verb plus noun. We would like to have the list of actors, an objective, a trigger, a result, and the basic flow of actions, and then the exception flows. We have numbers for the basic flow of actions, 1, 2, and the exception flows 1A, 2A. And with that, the AI knows that 1A is an exception of step 1. So you don't need any programming language or so. You can intuitively provide a template. So here's an example. This is how it looks like. And now let's do it for me. And now you can provide the use cases you had before. So existing use cases generated by AI, or it's from one of your documents. Give those use cases to this assistant. Say, now create the description of these use cases based on this template. And then you get something like this. And of course, then you must review it. But it's more a transformation task for the AI. It's not so much about generating new information, but you cannot be sure. You can, of course, you can put it in the prompt. Don't add anything new to it, but it's not 100%. So sometimes there's some new information in this. So in any case, you must review it. But it's much easier to review it afterwards than to create this yourself. So at least most engineers that I know don't really like writing stuff. So they like to engineer, but not to write texts. So this costs you then 10 minutes instead of an hour or 2 hours or whatever. It depends on the size of use cases. And of course, well, coming back to SysML, SysML textual notation. AIs like ChatGPT can generate executable Java, Python, whatever. Why not also SysML 2? And of course it works. And now we can provide or ask that this assistant now transform all these use cases into SysML 2 textual notation, and then you get it. Typically, nowadays, it's not perfect if you do that. I think because lack of the training data, there's much more training data for AIs about Java and Python on the internet than on SysML 2 textual notation, but that's a matter of time. And you can also provide examples. This is how a use case in SysML 2 should look like. Provide a simple example, and then you get it into exactly in that structure. So another aspect of using AIs is not only generating new stuff, it's also to analyze existing stuff. Here it's extremely simplified. So we provide a model in textual notation. It's a very simple model. So at the top you see we define a drone which has a weight. Then we have a requirement about a maximum takeoff weight, which shall be less than 200 kilograms. And at the bottom, we specify a concrete drone with a total weight of 190 kilograms. So, and it has a body, engines, control unit, battery. It's very, very simple for this example here. And now at the top, you see the first line of our prompt. We ask, so what happens if we install another battery with a weight of 42 kilograms more? And the response is, well, it's no surprise. Well, you are in trouble. Probably you violate the requirement. And some more. AIs are typically very chatty, so you get a lot of output if you ask it. So an AI can analyze an existing model, and you can, what happens if I change this and that? And it's for sure not a 100% complete impact analysis. But it's probably much better of that what you already have established in your environment, in most projects at least. And it also works if there's no explicit relationship in the model, because the AI has a kind of understanding of what is modeled there. So there is no explicit relationship between two elements. But if you say, I change this one, then the AI can identify, it probably has an impact on that one. A challenge is here technically, if you have really large models, to provide large models as an input into the prompt. Well, there are some limitations, but there are also technologies available for that. So do we have an AI team? The I in brackets here also points to the discussion about how much intelligence is really in AI. I will not open the discussion here, but for sure AI is not perfect. And we will see if it will ever be, but AI assistants are extremely helpful and you can start using them today. There's a nice paper published 2 or 3 months ago from the Harvard Business School, and it says that the introduction of AI dramatically reshapes the performance landscape. They analyze teams using AI and teams not using AI, or individuals using AI. And an outcome was that the introduction of AI increases the quality of the work, and it also saves a lot of time. So saving time and getting higher quality, well, that's not a bad deal. Huh? And so let's do it. Yeah, coming back to SysML v2 tools. Now imagine you have a modeling tool that you simply tell what you want to do. The tool creates the model for you. You have not to mouse click through everything there, and gives you tips what you could be improved. And if there are conflicts with existing artifacts, you get a hint. And if you don't understand the model, you get an explanation. And if you don't understand SysML v2 of this special element, you get an explanation, and so forth. That would be really, really great. And it would speed up the creation of specifications modeling enormously. And until recently, it was more of a dream, but now it's almost within reach. We already see modeling tools with embedded AI assistance. And that's just the beginning. Well, that's a typical topic if you talk about AI assistant hallucination. The AI does not always tell the truth. But that's not a blocker. I often get the feedback that's useless, that's hallucination, it's not always correct. Well, I have really, really great human colleagues, and they're also always not correct. And nevertheless, they are great help and not useless. So the AI is helpful despite of the hallucination. You can handle that. You must know how to deal with it. So that's not a showstopper. Yeah, and we have the same problem between humans. No? So the topic of misunderstandings in communication between humans, between men and women in particular, maybe, but also between humans and AI. You know? So it's there. So let's have a quick look on that topic before I show you a demo. Now let's have a more detailed look on human-to-human communication. So the following is based on the Shannon and Weaver sender and receiver communication model. Now, a person communicates with another person. So without AI, the challenge already starts with the first step. The left person thinks A. Now, A is the information, but the person says B. What you say is not what you think. And now the other person hears B, but understands C. So we have a difference between A and C now. And that's, well, that's a communication problem. A technique to avoid this is active listening. So the same scenario, but now the right person, okay, I understood C. I asked back, oh, I have understood, well, the person would like to say, I have understood C, but we know there's also a mismatch what I think and what I say to find the right word. So I have understood D, is this correct? And now the other person, well, understood, but then E, well, it's the same pattern as at the top. But now we have, it's more clearly on the table that there's probably a misunderstanding. No, I have not, not E, I said A. So that's active listening. So nobody said that communication between people is easy, no? So that's communication between humans and humans. And we have the same issue with ChatGPT, other LLMs. We talk with them through natural language. So you can replace the right side here on my slide with ChatGPT or another LLM, and it's a similar issue. Some of the LLMs also know active listening. So sometimes they do this technique. Oh, I have understood you would like that I do this and that. But what can we do? Well, something like this. We have an engineer, and now we can incorporate the expertise of a SysML tool. So why should the AI do the whole SysML job? So the AI asks something to the engineer asks something to the AI generates a response, and now transforms this to SysML and sends this to a SysML modeling tool. The SysML modeling tool knows SysML best, no? And the SysML modeling tool verifies now the response. Is it correct? Can even, if you have the digital thread, check if there's an impact on related tools, connected tools, and then we get the result back to the engineer, which can be textually by the AI, but also a SysML diagram. It says, yeah, that's exactly what I said. Now, if you talk with an AI about state machines, you don't want to do this completely textually. So this is a much nicer scenario, or the integration of an AI assistant in the modeling scenario. Yeah, so let's do a demo of that. I have no plugin, no special plugin, so I will use ChatGPT and a SysML modeling tool. And do the integration manually by copy and pasting stuff. So, well, life is life and shit happens, in particular if it's live. So I hope it will work. And the example is a company that develops delivery drones for harbor regions. So drones like this, that can deliver goods to ships in the harbor, like medicine or other stuff, and maybe the ships anchor outside of the harbor, things like that. So those systems exist, by the way. And well, we are already a company that develops drones, so we have a kind of a reference architecture like this one. It's already SysML v2 graphical notation. It's oversimplified. On the left side, you see our delivery drone system. So we have a set of drones and a single control station, and they are connected. And in the middle, you see the structure of our drones. And they have a navigation control, a propulsion, a power, cargo handling, and a body. That's it, nothing more. We have a starting point. So now let's switch to another tool. And I will put this on the screen. I think you should see it now. And what you see here is that's Visual Studio Code with an extension, which is Seaside. Seaside is a modeling tool which provides text notation on the left side and integrates the Tom Sawyer SysML v2 viewer, which is here on the right side. So it's the same model that I showed you before on my slide. On the left side, it's the text notation, and here you see another picture of it in the graphic notation. I'll zoom out a bit. Here, for example, our delivery drone, and you can see the details and so forth. So now switch to the AI. So it's here. No, wait a minute. It's here for ChatGPT. And I have prepared the prompts so that you don't see me typing here. It saves some time. So in prompt engineering, it's always good to provide a clear context and to clearly mark the part of the text which is the context. So let's start here with a context. And now you are a chief MBSE engineer of a manufacturer for drones for different sizes and for different purposes. And a harbor administration asked your company to build a delivery drone fleet to provide goods to ships anchoring in the bay of the harbor. And now we provide a clear set of instructions plus our base architecture that I showed you before in textual notation. So let's copy paste it in addition to this one. This is the context. And here are the instructions. So first, analyze the customer needs, then analyze the existing system architecture of your drone products given below in textual notation, delimited by triple quotes. It's at the bottom. Provide a list of 10 top-level requirements of the drone. Propose some disruptive, innovative ideas to improve the capability of transporting payloads. Then make a decision for a system idea which fits best for the customer. I don't provide any more criteria here, so it's completely up to the AI in this example. And propose the changes to the existing system architecture and provide the new architecture and SysML with textual notation. So a lot of instructions, but it's clearly stated. Now first do this, second that, and here's the textual notation of the architecture from before. So let's go with that. And it costs some time. So here's the answer, and I won't go into all the details now. Our AI system is a very, very chatty. So here's the customer needs analysis with different stuff. Then the analysis of our existing architecture. Well, we have multiple derivative drone instances, a ground control station, strength and gaps analysis. Then the top level drone requirements. And then the disruptive ideas, hydrogen fuel cells, ship-mounted magnetic pads, swarm AI logistics, and so forth. Then the decision on an idea, so selected idea is swarm coordinated drones with ship-bound magnetic pads landing and so forth. Then some textual stuff about the proposed changes to the existing architecture, and now the new architecture here based on our previous architecture in SysML textual notation. And because we already provided with our first architecture an example how SysML v2 should look like, it's probably correct. So it's it was really a new chat here in ChatGPT, so no further training. No? It's a zero-shot stuff here. So I can copy it, and then I have here a drone model new. It's empty. Let's put it on this side and paste. This is the output from ChatGPT. Copy paste. Of course, would be nicer if it's fully integrated, and it happens here. And now we can generate the new architecture. So we see here some new stuff in there, maritime landing aids and so. So here is the new top level of the architecture, and let's look into our drone, for example. That's inside. You see there's a difference. That's the new one. That's the old one. And I think that's really, it's simplified, but that's a really nice example, because we have an existing architecture and now we provide changes, and that's more realistic than creating stuff from scratch. So yeah, I mentioned we can change the roles. We can do something like this. So let's do another one. So now you're a safety engineer. The drones fly over populated areas, so special safety rules apply. First, identify the rules, make a hazard analysis of the new architecture, propose changes, provide an updated architecture. And let's go. Now we get a list of potential policies that we must follow. I have not mentioned it here. Of course, we can also ask the AI provide the references. Then you get links to the standards or whatever is behind that. Now we have a hazard analysis. And it considers our existing architecture of it, of course. So, and here are the proposed changes. So add redundant power units, enhance the communication system, introduce an emergency parachute system, so things like that. And then we get here the new architecture. And there's much more stuff in there. I will skip the copy-paste stuff to the SysML tool for this example. You have seen that before, that it works. Sometimes there are some errors in the textual syntax, but then that's easy to fix. Yeah, maybe one more example. Do we have? Yeah, there's some time left. Here's another one. So now you are again the MBSE chief engineer. To reduce the cost, you will buy a cheaper, less powerful, and heavier battery for the drone. Also a typical change in a real project, right? And now identify the impact of the change, provide a list of the impact in the architecture, provide a list of the 10 requirements of the system which cannot probably be satisfied anymore. Now remember at the beginning we asked ChatGPT provide the top 10 requirements. So we refer to those requirements here. And here's the impact. Now the weight increases, lower peak power output, reduce energy capacity, and so forth. Here's the architectural impact list. And this integrated in a modeling tool would be quite nice. Now, then it's here not a list in ChatGPT. You get a much better presentation directly in the modeling tool. Maybe different colors of the elements that are potentially impacted, things like that. And here are the requirements that potentially no longer satisfied with the impact analysis. And then that's the last one. So here. So now you are a sales manager of a competitor of the drone manufacturer. That's a complete role switch now. Your company is also interested in getting the order. And you got access to the system architecture of the drone manufacturer somehow. So you are allowed to use this information above. Provide a list of weak spots in the latest system architecture which you would use for a sales pitch for the customer. And then you get here, now the energy system is, of course, it's an issue. We introduce a new battery, which is cheap and heavy, and some other stuff. So this is really nice to challenge your ideas and your architecture, your requirements, your whatever. We don't have to read all the stuff here. No mention of cybersecurity. Oh yeah, we forgot cybersecurity. Yeah, and so on. And here's now the positioning summary for the customer. And would you like help preparing slides or one pager for the customer? Yeah, so jumping back to this one and jumping to the end. So, well, if you like to learn SysML v2, you can do this with me, if you like. I write books. I already have written books about SysML v2. We have a learning club where you can learn SysML v2, so clubs.oose.com. We have trainings. So I just came back from the US where I gave a Kickstarter training last week. Things like that. So I would be happy if I can help you. And with that, my last slide. So thanks for listening, and I hand over back to Max and Janet.
Oh, thank you, Tim. This has been very informative. We really appreciate you being here today. And so Tim's contact information is here on this screen. Also, we will be publishing this webinar to the Tom Sawyer Software YouTube channel that will be available very soon. And also I wanted to take a moment to share my screen as well. If people are interested to find out more about the Tom Sawyer SysML v2 viewer, or to find out more about the Tom Sawyer Perspective as a graph technology platform, which we used to develop the viewer, please reach out to us at tomsawyer.com. We can talk about these products in more detail, and also we have free trials available.